Welcome back to All This Math. This is Professor Parker. Listen, make sure you're subscribed to the All This Math YouTube channel. Drop a comment below this video. Also, like the video since you're here anyway. And also make sure you share this video with somebody that might benefit from it. All right, so look, this is what we're about to get into today. Many people call this the intersection method for solving linear equations. This is our equation right here, right? Now we're going to solve by graphing it, right? But the method that we use, some people call it the intersection method. I like to call it the divide and conquer method because what you do is you take this equation, you divide it up into two parts, with each expression being one of the parts, and you create two separate equations. You basically create a system of equations, right? So if you got one single equation, and then you take these two expressions on each side of the equal sign, and you set up a system of equations, all right? So this is what you're about to do. You take the first expression on the left side, which is 2, and the other expression on the right side, which is 6 minus 2/3 x, and you set up two separate equations. So the first one is y equals 2. That's a whole equation, y equals 2. Then the other one is going to be y equals 6 minus 2/3 x. All right, so we got those are two equations. So sometimes, like in algebra, you might be charged with solving a system of equations. A system of equations is when you have more than one equation and you got more than one variable that you have to figure out, right? Or you have to figure out the numerical value of, right? So now that's what we got. We got a system. We got y equals 2 and we got y equals 6 minus 2/3 x. So that's basically what we're doing. And you can solve any linear equation like that. All right, so anytime you see a linear equation, you can set it up and break it down or divide and conquer it, and it can become two separate equations, and then you can graph each of those equations. Or you can solve by any of the other methods of solving systems of equations. All right, now let's graph this one first, because this one has a slope of 0. Now, how do I know it has a slope of 0? I know it has a slope of 0 because it don't got no x term. Only way it could not have an x term is if the coefficient of x had been a 0. So if you think about y equals mx plus b, that would be y equals 0x plus 2. So this is equivalent to this. Because what happens when you do 0 times x? What happens when you do 0 times anything? That thing cancels out. So that's how you know the slope is 0. All right? It would have to be 0 in order for you to be left with just y equals 2. Whenever you see y equals a constant, and you should write this down and memorize this. Whenever you see y equals a constant is a number, a regular number, right? Could be positive, negative, big, small, fraction, decimal, whatever. That's a constant. The graph is going to be a horizontal line. Horizontal line, parallel with the x-axis. Means you're never going to touch the x-axis. All right? Horizontal line. All right? Y equals 2 is a horizontal line. Where do I graph it at? My y-intercept is 2. But every point on that line is going to have a y value of 2. So what I do is I'm going to go on the y-axis, not the x-axis, not the x-axis. I'm going to go on the y-axis, and I'm going to find positive 2, not negative 2, positive 2. So 0 is right here. And I go up 1, 2. And I draw that point right there. And then I take my ruler. Take a straight edge. Use the edge of a textbook. Use a ruler. Use whatever. Don't try freehand-it. Don't do that. Don't freehand it. That's nasty work. All right? And then I'm going to draw a horizontal line like such. And that's going to be the graph of this equation, y equals 2. Draw your arrowheads on the ends if you want to. That's one of the things I enjoy doing. So we got y equals 2 right there, right? And then we're going to graph this one. Now this one has a slope of negative 2/3. Notice that the order is a little off. Usually we have the x term first right after the equal sign. Whoever created this equation was trying to throw you off. Or trying to throw us off, actually. But don't fall for it, though. When you get the statistics and you're dealing with linear regression equations, then it's going to be written like this. You're going to have like y or y hat with the little v on top of the y is equal to a plus bx, basically. Bx like the Bronx or whatever. Well, I don't know. It's not bx. This is b. Well, it depends on what textbook. Yeah, it might be y equals a plus bx in statistics, right? But for our purposes in algebra, we're dealing with y equals mx plus b, or in this case, b plus mx. Now you might be saying, but that's a minus sign though. Yeah, plus a negative is the same thing as regular subtraction. Plus a negative is the same thing as regular subtraction. All right. So now, what's my slope? My slope is negative 2/3. So notice what I did. This whole fraction is negative. But when I use the slope, I got to pick one of the numbers. Either the numerator or the denominator got to be negative. One of them got to be negative. They can't both be negative, because if they both negative, mathematically, that's going to make the whole fraction positive. Because what happens when you divide a negative by a negative? A negative divided by a negative equals a positive. That's why one of these got to be negative. Only one of them. That's why the whole fraction is negative right here. That's why it says minus 2/3, right? Minus 2/3. That means the whole fraction is negative. In order for the whole fraction to be negative, only one of these can be negative. Not both of them. Not both of them. Only one of them. Because if both of them are negative, that means that you would be doing negative divided by negative, which gives you a positive quotient. And the quotient is the result you get when you do division. So make one negative. Now you could make negative. You can make 3 negative. It's up to you. I usually, my whole twist is I usually make the numerator negative, but it don't matter. It don't matter. So anyway, if it's -2, that means you're going to go down 2 spaces. And if it's +3 on the bottom, you're going to go to the right 3 spaces. The numerator tells you your vertical movement. The denominator tells you your horizontal movement. That's why some teachers say rise over run. I'm some teachers. Sometimes I say rise over run. Rise is the numerator. How far you rise is in your numerator. How far you run is in your denominator. Rise over run. Rise over run. All right. So now, but also my y-intercept in this problem is 6. So I got b equals +6. So look, I'm going to go on the y-axis because my y-intercept is 6, right? So somebody throw a pass, boom. The y-axis is like the defensive back or the safety that's going to try to intercept it. Where's it get intercepted at? It's intercepted at +6. So the wide receiver's over here, he ain't getting it. He ain't getting it because it got intercepted on the y-axis, right? So we got 1, 2, 3, 4, 5, 6. That's where it gets intercepted at, right here, right? Now, we use the slope. The slope is not a point. We use the slope to find the next point, all right? The next point. So we going down 2 spaces and then to the right 3 spaces. So we going 1, 2, to the right 3. 1, 2, 3. So we over here with it. All right. 1, 2, over 3. Following the instructions. Down 2, right 3. Down 2, right 3. Right? Numerator tells you how far to go up or down. Because it's negative, how do I know to go down? Because it's negative. If it's negative, you go down. If it's positive, you go up. It should make sense. This is positive, so we go to the right. Think about the number line. Where the positive number's at? To the right. If this was -3, we would move to the left. Now, dig this real quick. If I decided to make 3 negative, like we talked about earlier, and make the 2 positive, I would have a different point. Wouldn't I? Yeah, I would. My point would be, let me see, because I would have went down 2. No, I'd have went up 2. I'd have went up 2, and then I went to the left 3. But dig this, I'd have a different point. 1, 2, and went over 3. But it'd be on the same line. See that? It'd be a different point, but it'd be on the same line. That's why it don't matter. You could do -2 over +3, or you could do +2 over -3. It don't matter. You're going to get the same line. Because look at them points. They're nice and lined up. All right? It's like stair steps. Then you take your ruler out, and you draw a line through those 3 points. That's what you do. And we do this. Put the arrowheads on there. Now, just like we're solving a system by graphing, what you're looking for is the intersection point. This right here. But we're looking for the x value of the intersection point, not the y value. We don't care about the y value. We don't care about all that. All I want to know is the x value of the intersection point. X value of the intersection point. So the x value is going to be, let me see, 1, 2, 3, 4, 5, 6. Yeah, 6. So that means x equals 6. Let's go over here and check our work. So what's 2/3 times 6? 2/3 times 6. Actually, -2/3 times 6 is -4. -4. And then we got 6 minus the 4. 6 minus 4. 6 minus 4 is 2. So that means this is correct. X equals 6. All right. Now, go practice some of these. I got to run. I got to go pick a side up from dance practice. I'll let y'all later. Peace.